Let's do part A. We are given this function h of x equals the product of two expressions, that is negative 8s, negative 10 times negative 4s plus 1. And we have to find the h prime of s, which is the derivative of h of x, using the product rule. So this is the product rule. Suppose if we have a product of two functions f and g, and we find its derivative, and this equals f times g prime. G prime is the derivative of g plus f prime times g, where f prime is the derivative of f. So let's consider f as the first expression and g as the second expression. So we are going to use this product rule. According to the product rule, we have to put the f first. So I'm going to write f, that is negative 8s, negative 10 times the derivative of g, which is g prime, the derivative of negative 4s plus 1, and this equals the derivative of negative 4s is negative 4. The derivative of s is 1, so it is just negative 4, and plus 1, which is a constant, is 0. So g prime is negative 4. I put 4 here. Plus, we now find the derivative of negative 8s, negative 10. And this is, if we find the derivative of negative 8s, we get negative 8, because negative 8 times the derivative of s is 1, which is negative 8 times 1 is negative 8. And the derivative of negative 10, which is a constant, is 0. So it's basically negative 8 times, we have to put the g expression, that is negative 4s plus 1. Let's simplify this and put it in the simplified form. So we get h prime of x, and this equals, we will multiply or distribute this negative first 4 into the two terms inside the bracket. So negative 4 times negative 8s is, it's going to be positive. So it is 32s, and negative 10 times negative 4 is plus 40. Now we do the distribution of the 8 into the two terms inside the bracket. So negative 8 times negative 4s is positive 32s, and negative 8 times positive 1 is negative 8. And so this simply reduces to 32s plus 32s. These two are like terms. When we add them together, we get 32 plus 32 is 64. So it is 64s. Then 40 minus 8 is 32. So we get this expression 64s plus 32. And this is the derivative of h of s, which is h prime of s. Let's do part B. Here we find the derivative of h of s without using the product rule. So the first thing that we are going to use is do is we are going to FOIL this out and simplify and put it in the simplified form. So I'm going to write h of s, and this equals, I'm going to FOIL this out. So I take negative 8s times negative 4s, and this is 8 times 4 is 32. Negative negative is positive, and then we will have s squared. Now I take negative 8s multiply with 1, which is negative 8s. Now I consider the term negative 10, and then I multiply with negative 4s. So negative times negative is positive, so it becomes 10 times 4 is 40, and it is 40s. Now I consider negative time, multiply with the positive one, which is negative 10. Let's put this in simplified form. So we have h of s, and this equals 32s squared. This is negative 8s plus 40s is plus 32s. We then have negative 10. So now we have used the algebra to rewrite the given expression h of s as a simple term without products. So now we can find its derivative. So let's find the derivative of h of s with respect to s, which is h prime of s. And this equals, we have to find the derivative of each term one by one. We find the derivative of this term, as well as this term. So let's find the derivative of 32s squared. So here we use the constant multiple rule, and we just put the 32 as it is, and the derivative of s squared, and this using the, according to the power rule, we put the power in front and reduce the power by 1, that is 2 minus 1, and this equals 2s power 1, which is 2s. So let me put 2s here. Now let me find the derivative of the second term, 32s. the derivative of the 32s, and this equals, once again we use the constant multiple rule. So we put the 32 in front and find the derivative of s, which is 1. So 32 times 1 is 32. So therefore the derivative of 32s is 32, and the derivative of constant negative 10, which is 0. So we can just ignore that. So therefore we get 32 times 2s is 64s plus 32. So this is the derivative of h of s. We can now observe that these two derivatives which we have done in both methods, that is using the product rule as we have done in part A, as well as the one without using the part uh, product rule as we have done in part B, both are the same.